हाँ जी मैडम, you can start up.
Yes, sir. Okay, so I just have shifted to the ground level here, and if you remember, we have placed some of the rooms here, uh, and we have created a color legend for rooms, and also. So here I just want to, before going ahead, I just want to show you that how these rooms also can be scheduled. So if you remember that we have changed the color of the rooms, we just have changed the name of the room. Anytime these are the tags. So these rooms which I have placed in this spaces, they can be tagged, and anything which in Revit can be tagged, you can extract the properties of that particular element in the form of schedules or as a list. So here, this is a tag, and I just select this tag, and anytime I can go and I can add it that, okay, don't show me the room number, only show me the room name. So it is because this is a residential project, so here I would prefer to uh, place the tag only with the name. And if you want to, because these spaces are used these rooms are used for many purposes, like you can calculate the area of the rooms, you can calculate the, even if you have the finish here, you can get the area for the floor finish. Also, you can give the you can define the wall finishes, ceiling finishes, base finishes, all these things, and you can share the finishing schedule with the client or with the contractor. Or even you can for create, normally if you have seen the brochures which was given by the developer to the client, or a builder to the client, they have the uh, like finish information also with the rooms. So similar kind of information you can actually create in the by placing the rooms. So here I just go to the view, and in view you have the option of schedules, and we can create the schedules of the rooms. So just search from the rooms from the list, and we can categorize, we can quantify all the categories here, whether it's a wall, whether it's doors or windows, even the railings, anything which I want to. You can see that the railing is also here. Whatever the, if you have used any staircase, if you have used any ramps, everything you can you can get the quantities used in that components, and you can even get the number of components also. So but right now we are going to create the room schedule. So I just click on this rooms and I'll say okay, and now you can see that I can get the room area. So in this dialog box in schedule properties, there is two fields. One is the available fields and one is the schedule field. So you can extract this field towards the this right hand side like area, and then uh, I can add the base finish right now. Even though we haven't mentioned any base finish, but definitely if we give the finish, it will get populated. And then we have the count also. Uh, you can have the on which level this room is, what is the name of the room, what is the number of the room, that also you can do. And then even you can add the occupancy of the room for um, like maybe for different purposes, but right now we are creating the finishing schedule, so I'll add this wall finish, and maybe you can add the height also. Okay, so once this field has been added on in the schedule fields, you can move it upward or downward depending on how you want to. place it. So first of all, I'll place the name and then the area, and then I want the count in the last. Or maybe you can add the schedule fields, but you can hide it also when if you want to export or you want to just you are going to use it for some other purposes. So you can go to okay, and now you can see that the room schedule is ready. So once you will add the base finish and ceiling finish and the wall finish in your room schedule, they will get populated. But definitely we have to give them. So we just concentrate on the areas. Now you can see that it's showing me the area for whatever the room I have placed in the ground floor level. It is showing me the area of those rooms. That for the bedroom one, we have the 26 square meter area. For toilet two, we have four. Toilet one also 4 square meter area. Then for the bedroom two, we have 17 square meter area. If any time, and also it is giving me the count. It is giving me the levels. You can sort this based on the levels, and you can add a header over that every level. And I'll say okay. So now you will see that ground floor level has been and even also you can go to sorting and add a blank line, so that first of all it has a ground floor level room, then first floor level room, and then second floor level room. It is also giving me the unbounded height. So actually schedules are also not only this is for the giving the information, they are also for the checking, for the for validating the data. So maybe if I have added the unbounded height, even though this unbounded height is not required by the contractor, but I have added that into the schedule so that I can check whether anywhere I have a height which is different from the height which I have mentioned. So you can actually verify the information with the help of schedules. And also if you like maybe in one of the room, I want the height should be lesser on this unbounded height. So what I can do, I can go to that room by highlighting in the model. So it will take me to that room. Okay, so this room is highlighted, and I can, instead of this, I just want that the upper limit of this should be ground level and the limit offset should be 2700 something. So you will see that in the room schedule that the height has been changed here. So you can actually, if you I can change it from, again, I can highlight this toilet room and I can close and I can go to the properties and make it bigger. So it's not up to the first floor and it's just the room, the calculation of the area will be till the 2700. So you have all these, you can see that this information has been updated here. So room is the schedule is the uh, live view of your is one of the live view of your building, and the all the data in this is live. So if you make changes into your building, this schedule will get updated, and anything which you update in the schedule, it will not in every case, but in some of the cases that will get added into your model or a building. So you can create your finishing schedule like this. Let's go back to the ground floor level again. And I just want to, if I want to add the finishing uh, uh, with this, so what I can do, I can pick this room, and by clicking, by tabbing, you can pick this room, or otherwise, if you go to the visibility graphics override, so VV is the shortcut key. So, and from here also you can actually highlight, just do it quickly. I know that this is going so I just click OK, and now you can pick your room easily. So you have this reference lines here. I just remove it again and I can place it with the tab. And then I can add those finishes. So maybe the wall finish which I want, that is can be acrylic emulsion paint. So You will see that once I add this information, there in the wall finish, you can see that this bedroom uh, information has been updated. Now in the, because in toilet I want that ceramic tiles, so I will add this information, ceramic tile. So you will see that if I go back to the toilet, toilet. So you can see the wall finishes for the toilet ceramic tiles has been updated. So again, if I go and I say anti-skid tiles for my flooring in the toilet, then also for the toilet one also you can select, but I can do that in the room schedule. So for the toilet one also, I'll take the ceramic tiles, and for the floor finish, I didn't add the floor finish, I think, in the room schedule. So if you can add it later on, let's go and okay, the floor finish and move it up near this, move the level up. Okay, so this is now sorted, and then toilet one also I need the anti-skid tiles. So you can see that the information which I put in the model, it will get populated in your schedule and vice versa. So this is the power of BIM, and this helps. You can create the schedules with the help of these parametric properties of the elements uh, sh- uh, of the Revit. Okay, so here you have this family room here, and now I just go to the room schedule and I add the I can do it from here. I want the same, maybe I want the uh, wallpaper for family room, and even for the so I can select from the list whether for the living room I want acrylic emulsion paint or wallpaper. So I can go and I can select this from the list, and I can populate these area. For bedroom 2 also I need acrylic emulsion. For kitchen I want ceramic tiles, or so this way you can go and you can, for the staircase area, I'll prefer to have the distemper. So there is another has been added here for the front area. I would like to have the distemper, and for the real also I would like to have the distemper, wall distemper. So these wall finishes has been added into the in your room schedule. So you can name this as a room finish schedule, and this can be used with your floor plan. So this room finish schedule can be used with your floor plan and can be shared with the client for giving the information about the rooms and the finishes used in the room. And this information is not only just for the this room information is not only for these purposes. These rooms are very important even for creating the for calculating the energy of energy, for doing the energy analysis also, because depending on what material we have used, and what is the area or volume of the room, and what is the type of the room, based on that the occupancy, because if you go to the field there is another parameter which is occupancy. So you can even define the occupancy of your room, and based on the occupancy the energy, you know that energy uh, energy requirements gets changed, and based on the based on that your design needs to be changed based on the you need to have the maybe more lighting, or maybe you have to have the more air conditioning or heating, depending on the which location is your building. So you can create the schedules like this. Now we just go to the ground floor level again, and I create another duplicate of this particular view with the detailing. And okay, and I don't want this color fill here, so I switch off this color fill and just put it in. It's always better to make the, so I have switched off the color fill from this uh, ground floor plans. Now, we already placed some of the furniture here. Now you can see that. So for interiors of this, we can actually create the ceilings for the rooms. So I just go to the architecture and I place some ceilings. Ceilings are also very important for why these are important, because ceilings bound the room. So when you place the ceiling, whatever the height you are placing the ceiling, actually this ceiling is bounding your room. And this is actually enclosing that space for the analysis purpose also. So I just place the living ceiling here. You can create the automatic ceiling just by, then it automatically picks the walls of that space. So this is the automatic ceiling which I have placed here. For seeing the ceiling, you have to go to the ground floor ceiling plan. And here is your ceiling. This ceiling can be plain, but I'll prefer, so that you can see it properly. I will prefer this grade of 600 by 1200 grade. So you can see that this ceiling is placed here. And similarly, I'll just delete this ceiling. You can go to ceiling, and for this I will pick this sketch ceiling option. So you can sketch your ceiling. Maybe I want my ceiling something like this, and then I want to offset this at a distance of 1 meter. So one ceiling which I have created, that is the plain ceiling at a distance at the height of 2600 from the ground level. So I just created one ceiling here. Then I'm going to create another ceiling at a, so you can actually create the multiple ceilings in, so sketch the ceiling and another ceiling at a height of 2400. And if you check the section of this room, you will see that two ceiling has been placed here. Then we can use some tools to create a cove here for the lighting system. So we can use those tools, like you can use even the wall tool, or you can have your uh, this wall sweep tool also you can use to create that kind of cove around the ceiling. And so this way we can place the ceiling. So let me place the ceiling on this ceiling can have any material. It could be POP, or it could be gypsum ceiling, depending on what kind of project you are doing. So the ceiling has been placed here. So once the ceiling has been placed here, you can place the ceiling elements. You can place the lighting fixtures into this. So to place the lighting fixtures, you have to go to the system. And in system, we have this lighting fixtures. We'll pick the lighting fixtures. So no lighting fixture family is loaded here. So I'll go to the project library, Revit library, and I will pick a lighting fixture. So go to lighting. You can pick there is two type of lighting. So there is a architectural lighting and there is a MEP lighting. But if an architect does the project, place the lighting fixture in the project, they use the architectural lights. But if any electrical engineer is placing the lighting fixtures, they use the MEP. So I just go to architectural, go to internal. So you can see that there is different lights here. There is a ceiling light, round light. There is a linear box light. So you can pick any of the light here. Then you have some down lights. This is for different purpose. Then you have the floor lamps. You have the pendant lamp. So any of these lights you can pick from here. But because I'm placing this light in the ceiling, so I pick this linear box light, and in linear box light I have this 600 by 1200 two lamp light, and I can place this light. Maybe we can have the another light also, ceiling flat round, and you can place these lights right here. So you can place these lighting fixtures. Let's quickly place the lighting fixtures in other rooms because we need data for this. So um, you need to create some line work for this so that you place the lighting fixture at a equidistance, and may, uh, it should look aesthetically appealing. Even you can use align tool to align them. So, so this way you can actually place the, I just create another one also here in the alignment. So this light has been placed. You can create the ceiling in a multiple levels, but this is just a plain ceiling and I have placed the lighting fixture into the ceiling. And if you check the section, you will see that the lighting fixtures has been placed on the ceiling, and I don't want this to be here. Let me check the. You can change the crop view of your section so that you see what you want to see. Okay, fine. This is fine. And now you can place some other uh, lighting fixtures also. So I just go to the fluid family and take a pendant light. And I just go to system lighting fixture and I can place this pendant light. So if we need to change some parameters in the pendant light, we will go and we can. So the Most of this is the candle light is placed here. Uh, and this is not suitable for this area, so I just bring it here and place it in the kitchen. Basically, so let's go to the lighting picture. Sometimes I take this one and place it. Just place one light here. Maybe we can find out the sometimes the because these lights are also based on the host. So some lights are floor-based lights, some lights are your ceiling-based lights, some lights are wall-based lights. So you can even place the wall lights, but for that you have to go to the sections and you have to place the lights in the sections. So I just go to architecture and go to component and we'll check out whether we have any light which we can place on the node. New family and we have wall light. There's only wall light. So we have this light which we have. So these kind of wall lamps. So you can have more lights from the Autodesk library and you can download more lights from here. So depending on the template, sometimes you don't get much of the options. So you, in that case, then you have to go to the Autodesk library and there you can load more components. So this way we have placed some of the lighting fixtures here. Let's make the these all these schedules. So we just go to the view and here we just go to the schedule and quantities. And in schedule and quantities, I just go to lighting fixture schedules and pick it lighting fixture schedules. In lighting fixture schedules, I can add the count of the lighting fixture schedule. You can even add the cost of the count, lighting fixture schedule, family and type. Then you can add the level, lamp, which has been used into this, luminous plugs into this, and maybe if you want some wattage or all that, that also you can add. And also you can add the type mark. If you have given a name to this L1, L2 or something like this, you can give it in the type mark list. So you can see that the lighting fixture schedule is ready, and it is showing me that these, because we just placed the lights only in the ground floor level, so it's showing me all the lights in the ground floor level. And if I want to get the total of this uh, by the family and type and client, so you will see that it is giving me 18 lights is the ceiling lights flat round, and one light is a wall lamp light. Similarly, we can create the schedules and quantity of the doors. So in the doors, we will take that type mark, we will take the width of the door, we will take the family and type like single flush, single panel, double glass. So that is family and type. If you want to add something like frame material, if you have assigned the material, so you can add the frame, what type of frame you are going to use into this, and then uh, what will be the head height of the door. If you want to add the manufacturer, you can add the manufacturer of the door, and also you can add the fire rating of the door. So these parameters are already in the door properties. So you can define these parameters and can get your door. So the manufacturer, you have to give yourself that who will be the manufacturer of the door. And for fire rating also, whether the door in the front door and the rear door will be having a fire rating of 2 hour fire rating or 1 hour fire rating. So you can define those properties for a bigger, for public buildings. This parameter is very, very important. And also this can be used for maybe for a later for operations and for other systems. Now we have this type mark here, and every door by default gets some type mark, but it's giving us 42, 41, something like this. When I go to my ground floor level plan, I can simply click here to any of the door, and I can tag those doors. So how to tag the doors? And annotate, and I just simply go to tag all, and I select the door tag and say apply. Okay, and you will see that our all doors has been tagged there, and some of the door hasn't been tagged, so we have to tag them manually. Okay, we can do it later on. So here you have these all your doors which are having the similar type. They are, I just go and edit this. And I just want to show you that if normally, we can edit this, and we can actually we modified the tag family. So now in the project you will see that sorry, we didn't load the family. Let me edit it again. And I add the type mark from here. The type mark is the type property. Like if your door is a 900 by 2100 door, so all the doors which are 900 by 2100 and single panel doors, they will have the same, they will have the similar type mark. Like normally in a plan, you see that D1, D2. So this has been defined with this. The D1 is 900 by 2100. D2 is 800 by 2000. D3 is 750 by 2000. So something like this you normally you see in with your floor plan. So this is about the doors. door schedule which you get in your floor plan. So this type mark which I have added here, it will give you that property, and I just load it into the project, override. So you will see that all the doors, I just go and I select all the instances visible in view. So you will see all the doors which are 900 by 2100 has got the type mark 41. Normally in Revit, it automatically gives it 41, 42 like this. So if I go and change any of the type mark from here, uh, I can define it D1, or we have main door also. So I define it D2. So you'll see that all the doors which are 900 by 2100 has got the type mark D2, and even you can check it in the door schedule. You have got these D2 doors. So there is uh, uh, there is many doors. And how many doors? Just go to the fields and add the count field here, and you will see that by sorting and grouping by type mark, get a blank line, give me grand totals. Okay, so now it is showing you have 4 count of the, sorry, you have 12 count of the D2. Similarly, for this 42, I just highlight it in the model, and it will show me that which doors are these. This is the door which is 800 by 2000, which is placed in the uh, kitchen. Okay, fine. So here you can, even in the door schedule, you can add the information about the room also. So when I go to fields, instead of door schedule, I can add the room information also. So room name. So in which room this door has been placed. So the name of the room, I just add here. I bring it up near the type mark. You can there's many things which we can do with our schedules. So now you can see that this 42 has been placed in the varies room. Why? Because according to the levels, we didn't add the levels. So let's add the level also. And in the sorting and grouping, I just do it by the level also, so that you see. Okay. So it's showing me all the 42 number. It has been placed in the this. These are opening, and in the, so there is, okay. Sorry, I have to add the field 2 rooms because it's opening in the kitchen, and 2 rooms. Wait, I can find it out. Okay, so now if you see the here's the level. So there is your ground floor level, this room, uh, the 42 number door, and it is giving you the, how is it giving various information? Sorry. Uh, right. Let me check this. Let, we have 42. Okay, we have 42 here also. Okay. So if I go to the room schedule, sorry, door schedule, and I do the sorting and grouping. So you can see that we can extract the information in any format. So instead of here, I just select, first I select the level, and then I select the to room name. Okay. So you can see that here it is showing me that this 42 is from the it's in the kitchen and in the staircase, and it's opening in the kitchen, and it's from the staircase side. So you can add that information also into your door schedule, and just a blank line here. Okay, and I just use the type mark also. So it is giving me that D2, which is in the bedroom one and opening in the staircase. It has the head height 900 and the width 900. Then D2 is in bedroom two. So you can extract information, whatever the format you want. You can extract that information. Only thing is that that information uh, should be in the parameter of your component. But Revit doesn't stop us there. We can even create our own parameters, and we can add more and more information with our components. Like if I want to add some time information with the components, I can add that information, and I can use that information for project for project management. So I can project timeline. So that information also we can add into our components. Uh, so I just go back to the ground level again. Uh, sorry, ground level copy one where it is. So let's change this to D3. So you can see that both the doors has got changed, and even if you see in the first floor, this if we haven't tagged in the first floor, so tagging you have to do in every floor separately. So we just go to annotate, tag all, and door tag, apply. Okay. So, so this door tags has been, if any time you couldn't, there is no door here. I just take the D3, create similar, and I place this door here. And if I want to add the tag, it will show me that this is D3. Similarly, you can change this toilet doors to D4. So you will see that all the toilet doors has got name D4. Uh, Even in the ground floor plan, this has been named. So this is the power of parameters and parametric software, and you can use that information for when that's why you can use that information for planning, for construction, and even for facility management. Even for quantity extraction. So this way we can have these schedules here. Then so quickly I now we have the another type of schedule, which so in the quantity section you can even create a schedule which is the material takeoff. So if we have assigned the material to our elements like walls, floors, and maybe for the even for these doors also, you can extract that information and can get the estimate of the with the help of that schedule. So you can create a material takeoff. So that's why I have added the layers into the wall. So I just go to the walls and select the wall from the category name and create the wall material takeoff. And in wall material takeoff, I will add the material name first of all, so that I know. So material name, then material volume, because some of the material area and volume both we need material area. And if you want to add the family and type of the wall, you can add that family and type so that you know that in which wall you have which material. And then even you can add the volume and the width of the wall also. So width of the wall will be added. So we have got a big list of the so all the walls from ground floor to till multi-roof level. It's showing me in the list, and you can hide this like just to verify. You can actually check the. You can add this parameters family type into this, but to share it with other anyone else, I would like to hide it. So I just hide it. I want to give only uh, the material name, material volume, and material area, and I want the total. So for just go to the sorting and grouping, and according to the material name, give a blank line in between, calculate the grand totals, remove the itemized from here, and you will see that brick common, concrete, default wall, rendered, which was actually our plaster material, and then we have got wall texture stucco, but we are not getting material volume and material area here. Why? We have to go to the formatting, and then for the material area, I have to tell to the software calculate totals, and for volume calculate totals. And now you can see that you have the material volume, that the volume of the brick, then you have the volume of the concrete which we require, and then there is a one default wall material. We have to check that in which walls it has been used, and we have to change this material. Then we have the area for the plaster, and we have got the area for the stucco plaster. So we have got all these materials here, and even I don't want the if you don't want the go to the sorting and remove the grand totals. So we have got the material takeoff here. So now we have the we can now we know that how much brick has been used in the project, how much concrete volume has been used into the project, and how much area we need to be plastered with the this interior plaster, and how much area we need for the stucco plaster. So Revit helps us to quantify this in just one click if you have shared the right information. So this is how we create the schedules for quantity extraction. How we create the material takeoff. So material takeoff is also a schedule. The only thing is that it gives you the material of that category. And if you want to get the material the material used in the whole project, like how much brick used in the whole project, maybe in the wall or maybe for other purposes. How much concrete has been used in the project, maybe for in the column and in your floor and in your roof. So you can calculate that with the help of material takeoff, and you can select multi-category options also. So we can have a schedule like this in the we can create the finishing schedule, door schedule, window schedule, lighting. I mean, we can have the schedule of everything. Even we can have the create the schedule of furniture, and we can share it for the for with our vendor, and uh, we can get our furniture ready with this option. Now the next thing is that you can even place the, as I said that the project, we can do the plumbing designing also here. So you can place the plumbing fixtures also in your project. So go to uh, again go to systems, and in system we have plumbing fixtures. We have to load some plumbing fixtures, and plumbing fixtures are into the plumbing folder. We go to the plumbing, and in plumbing we have fixtures, and I want this water closets. So you can have this water closet, which is wall based water closet, and you can place this water closet somewhere here, and then this will be right here in the closet. And then I load another family, that is shower. You can change the parameter of this. I think we have the most shower families also available. So this is just for the drain, so no problem. Okay. And so we have what is wash basin, small wash basin, but yes, you can have a bigger dimension. This is 200 by 300. So do we have any? Yes, we have this 560 by 560 also here, and you can place this and can this also 5, 5. And now these elements has been placed, so you can even copy paste these elements. Some of the elements can be copied, but not every element. But we'll see that uh, because they are the wall-based elements, so maybe they need. Let's put this one and copy to clipboard, paste it on the other levels, first floor and second floor. Okay, and let's see. Okay, so these got copied on the first floor and hopefully on the second floor also. And this place it here. And now we can, once this has been placed, you can go and you can create the schedule and quantity of the plumbing fixtures. So quickly I'll show you that. Count, manual type, manufacturer, on the level, which level you want, then what system it belongs to, if there is some system name, system type. So this there are many properties which according to your requirement you can add in your schedule. So it is showing you the level. Manufacturer, definitely we have to give on our own, because according to every project, the manufacturer is architect's choice or the plumbing designer's choice. And there is this family and type which has been used. It's placed on this, and you can add more and more. And we can sort based on family and type. Give us the blank line, grand total. You can see that three number laboratory on the 14 and 15. And add the level also. So on the ground floor, we have got laboratory rectangular 2, and then we have the laboratory rectangular 560 by 560. Then on the first floor, we have this shower stall. On ground, we have, so ground first and second, we have this shower stall, which are two numbers, and two number. And if you don't want sorted by the level, you can remove this. So it will give you the total. So whatever the total plumbing fixtures you require, it will give you the total. So you need three lavatories, 560. You need three lavatories. They are, I mean, I don't know. Maybe by placing, we just change it to, it will be public only. We will see that. So we got six lavatory. We got six shower stall. We got five toilet, three at a 380 seat height and one at a 480 seat height. Maybe when I was placing, this has been placed at a different type of has been placed. So that's why we got. So it helps. It tells us that I have done a mistake. So what I can do, I can highlight in the model, and I can change this to the other type. So you will see in the plumbing fixture schedule now on all the levels, the plumbing fixture are similar, and it is showing you the total count on these levels. So this way I can hide this, because this value we don't want. You can get the total number of the plumbing fixture schedule that you have used in that. Okay, let's go back to the ground level, and create the site for your project. So for creating the site for the project, I will go to the site view, and I have already created this uh, uh, property line here. So how to create this property line, I show you that. You just have to go to massing and site, and you can click on this property line, and you can either you can create property line by the your coordinates. So you can give the distances and bearings. So you can create this property line if you have the coordinate from your surveyor. You can create the property line based on that. But if you don't have that, you can create it by sketching. So any of the option you can try, or even you can bring the AutoCAD drawings by the surveyor in your project, and you can acquire the coordinates from that AutoCAD drawing, or you can replicate those coordinates in your Revit project. So here I just create one property line for you just by sketching. Uh, Otherwise, already I have created this one. Let me uh, edit this. So you can edit this sketch. So this is just a line which has been created. But after creating this line, I have assigned the coordinates of these property line. And if you will see that this has a very uh, I just go to manage and I specify the, sorry, I just go to annotate and I put coordinates here. So you will see that I'll show you that. So this is showing me that my the north is at -11420, and my east is at one -103 meter. And also, if I specify the coordinates of this point, so this is showing me that this is -1140, and east is this, and this coordinate of this point is that. Okay, so I have already defined these points, but anytime if I maybe surveyor has given me some information, I have changed the coordinates here, but later on we realize that okay, the coordinates got updated. So in that case, what you can do, you can go to in Revit how we assign the coordinates. You just go to manage, and you can have an option of specifying coordinates at a point, and you can specify the coordinates, and there is a north south coordinates, and there is a east west coordinates. So in when you check it in the Google Earth, the north south is your y coordinates, and east and west is your x coordinates, and this is your this is your latitude, and this is your longitude. So you can actually convert those coordinates. Uh, Normally, surveyor gives you those coordinates. They just give the coordinates in x and y. But if you don't have that coordinates, and you just want to use the Google Earth to locate your plot, project, site, and to acquire the coordinates from there is different ways to do that. Sometimes we bring the surveyor file, sometimes we just uh, from Google Earth we can export the KML file, and that KML file again can be converted in SketchUp. You can take it in the SketchUp, and you can convert that into the uh, in your CAD file, and then you can bring that CAD file in Revit. So this is one of the way to do that in. So this is how we geo coordinate our project. So we can actually define the coordinates of the site, and based on the site, the coordinates. If you check that this is a project, this is called project base point. The project base point coordinate has got changed. So normally, this, if I start any project, let me show you that, because we don't have much time. So I just uh, uh, transform the coordinates uh, from the Google Earth, and I have placed those coordinates. So, but I show you that. So here you can see this is showing you the project base point, and the project in the project base point, it is the north and south has got change, and the east and west also has got change. But otherwise, if you open the new project, it's always at 00. So now it has got relocated. My project has got relocated according to the site, or according to these coordinates. So my project has been, and also in the here you can see that the project is, if you check it in the ground floor level, or you'll see the project is it is placed, the north is placed somewhere here. But if you check the site, the north is placed somewhere here. So because why? Because my project is 180 degree, because according to these coordinates, the project location is, the true north is 180 degree from the project north. So that's why it's showing you the this project. But if I change the site view to project north, you will see that the project location. So sometimes the north is at an angle. So in that case, also, if I see the project north, it is always on the top. But if I have acquired the coordinate from the surveyor drawing, then the true north will give me the true location of the project. There was no angle in this. It was like this project. Project. The site was actually site coordinates was the project location was at a it was aligned with the these south and north in the south and north alignment, so at a 0 0 angle. But if you have a if your project is located maybe your site is located 180 degree or some not 180 degree, sorry, maybe 15 degree or 20 degree towards the true north, then you get this option here. So you can set your project according when we are working in the plans. We always work with the project north, but when we work in the site, we just have the option which our site should show us the true north, and that should be shared with the other stakeholders and also with the client
Yeah.
or for the site execution. Yeah.
Anju ma'am, I wanted to
Yeah.
add something over here.
Yes, Manas, please.
Yes. So I'll share the screen if required, but it's fine. You can keep the share screen over there. Uh, so as
I just stop presenting. You can
right,
share your screen.
absolutely, I will do it. So we were talking about the geospatial, how the geolocations and the geospatial kind of linkages is there between a BIM model, and how the latitude and longitude basically can be. I mean, Anju has covered a bit, but I want to make it from a point of view of a planning engineer. Say so from the very first thing that when we are in the planning stage of a BIM life cycle, so in we have a in that particular stage we have to have the data sets. So what type of data sets we may require for different type of planning? We may require data sets regarding the environmental conditions, like the temperature, the wind velocities and other thing, because very important is in BIM, when we are integrating with the GIS data, it is very important that there are a lot of decisions which are made on the design of the building or the implementation of building depending upon the environmental situation. Now, why we require? Because when we do an energy analysis, when we do a carbon demand analysis or a carbon footprint analysis, or there are a lot of analysis that can be done before the design has to take place in the conceptual stage. So I will just give you some of the ideation of how the site looks like, and how the site can be thought of in a digital environment in the BIM platform. So what exactly, I'll just share the screen and then I'll talk about what True North is actually all about, and what basically the Project North is all about, how we can look into the mean sea level, how we can basically coordinate our drawings or the models as per the survey data. Survey data means survey elevations like northing, eastings, and the elevations, right? So I'll just give you a brief idea what Anju has talked about. Let me share the screen. So I'll be first of all opening the Google Map, and then I will be taking you to the Revit screen. Just give me some time. So here when we talk about the latitude and longitude, so latitude or longitude is basically the northing and easting actually of a particular point or a particular parcel or a particular geospatial location, because anything in the map or anything in the geography is any point or any location is located on the basis of its latitude, longitude and elevation. Now give you a typical example of it. So I'm just sharing the screen. Anju ma'am, if you feel that if you want to come and add something, you can be with me, right? So
Okay, Manas.
Yeah, sure. So here you can see that, let's say we want to pull the data of Chandigarh or any other place. So here is the Google map over here, which is huge. And another thing is that I'll tell you that from this Google map or Google Earth document or the models, we can also create KML and KMG file, and we can bring it into our Revit for various data analysis. So we can talk about how things can work in Revit or Civil 3D or InfraWorks. There are different softwares in which basically these kind of analysis like watershed analysis, or you can also go for runoff analysis. You can do basin, you can also find out different kind of landforms analysis you can do, especially the watershed analysis we do for various kind of planning for underground utilities. So summing up these things, so I'm at a Google map, I can share you. Let's say what is a northing and easting and what primarily in Revit, why, how do we fix it? This latitude and longitude, and why it is required, the latitude and longitude I will talk about, and then how we fix the coordinates in the site. So I'll give you a typical example of a site, how the site works, how the shared coordinates, because this particular demonstration in Revit would be more into shared coordinates. What is the shared coordinates? How does it work? So you will get an idea about and why it is required in the process of the building life cycle, starting from shadow analysis, energy analysis, carbon wind tunnel analysis. So there are a lot of analysis that you can do in the model during the design phase, from conceptual phase to design phase. So I will talk about in the next session, I'll talk about the building life cycle, how it works, and then we will talk about what is a common data environment in a BIM model. So till now we were talking about Revit, we're talking about BIM. Now in the next phase, we'll be talking about what is a CDE and what does CDE means in a integrated project delivery. IPD is one of the terminology that we use for the delivery of models. So I will talk about the various languages of BIM, how the deliverable, IFC, IPD, CDE, and how does it work. So just as we mature towards the understanding of the software, we will be more talking about more languages of common data environment and BIM. So here you can see there is a site over here. So we can, if any site that we want to search, let's say I want to search a site in NITTTR Chandigarh. Now, one thing that you can search the site over here, let's say, so here, this is the site of NITTTR Chandigarh. Now, what I can do with this, how can I locate it in Revit, this particular site? So here you have this at the top, here you can see there is a value of latitude and longitude. So you have this data over here. So you can copy this data. And apart from that, you can see that there is a 76 points. So there are three datas over here. One is the 30.7290776 and 76.80. See, this is the lat long data, as well as this is the MSL data. This is 87 meters above the mean sea level. So now you have got three data that you have found. Now you want to attribute, you want to use this attribute into your Revit locations. Revit, you want to geosynchronize it with Revit. Now, how do you do that? So to do that, you go to the manage option, manage tab here. So you have this location tab, specify the geographic location for the project. Now, what do we do with when we see this particular dialog box? So you see this, there are two things that you can see in this dialog box. One is the location and the other is the site. There are two tabs over here. Now, what is this location? Now, location is the latitude and longitude of that particular site or the sample site for which we are doing the analysis or for which we are doing the modeling. So it is very important to fix up the latitude and longitude while you start the project or during the project, because while in the process you can basically export the data as a GB XML, which is the another X markup languages for various analysis, data design, daylighting analysis, lighting analysis. You can use this data if you have the proper location. So we'll talk more about this language later on, but let's put this data over here as the project address and put the values that we have captured from the, so we are capturing the data from the site, and we have this, we take this lat and long and put it here as a project address. Now, the moment we put it and search it, you find that the address is over here, and you can see that there are different weather stations over here. Now, weather stations are basically the stations which records the temperature and all the psychometric data of the particular area, like the rainfall, like the wet bulb temperature, dry bulb temperature during the entire year. For example, all the data is regarding. So with this data captured over here, and there are some real-time data that are fed into your model, from which you can do various kind of analysis for planning of the building. So now you have this project address, and then you can select which weather station you want to pick. Now, depending upon this weather station, so if you take this weather station over here, now you have fixed the weather station and the location, and which is now here in the project location. Now the site address is fixed over here and the weather station is fixed over here. Now what will happen is, based on this latitude and longitude, whenever you go for an energy analysis, whenever you go for a heat load analysis, whenever you go for a carbon wind analysis, or any kind of analysis which is dependent on weather data, this particular address will help the software to as an indicator and get the data for the analysis. So it is very, very important. Now, the other thing is that how do we basically fix the another part, which is the 87 meters over here, you can see. Now, the other way of doing is, let's say, if you see here, this particular, there are two coordinates over here in Revit. One is, I mean, two origins you can see in the BIM space. So I'm talking about BIM space currently. BIM space means when we are planning a model, planning a design. So it is a building information or information modeling space. Now, what is this? This is a point which is called a survey point. Now, what is a survey point? Survey point is the point of reference from where the site is basically referred. Now, for example, I'm taking a site over here, which I want to build. Now, over here, other thing is that we will talk about what is a project north and what is a true north. Now, let's take the site campus over here. Let's say there is a parcel or a building over here in which we are going to understand what is a project north and site north. But before that, let us understand the coordinates. What are the coordinates all about? Now, for example, you have this particular two coordinates over here, and let's say this is the site map of a particular space. So let's take an example here. So I'm taking a sketch, I'm creating a sketch, and let's say this is the entire site of a particular campus. Let's say a campus. Let's take a hypothetical example. This is a site of the, which is particularly, let's say 60 or let's say 70 meters, and let's say, and this is something. So this is a typical example that I'm taking so that you can understand about what exactly. So here, this particular survey point is the point, is the benchmark from where all the parcels or the lot lines or the building is referred as. So let's say you have got different blocks in this particular site. So let's mark these blocks over here. Let's say you have a block over here, which is an administrative block here. There is another block over here. There can be another block over here. So you have got different blocks over here in this particular site. And this block, every block would be having its own north. That means north means not about the true north, but about the front, side, left and right. So let's say if this is a building block, this building block, if you want to construct it, this particular site of this block, you need to have an origin of this particular project. So this is one project, this is another project, this is another project, there are 4 projects that has to be built and has to be coordinated into the site. Now, shared coordinate is a coordinate system that all of these particular site are sharing with. For example, if this is a project base point, that means now over here, if you see, this site survey point is having a northing and easting which is disabled, which is 0 and 0, and elevation is 0. But here, if you see the project base point of this particular site A, or this is a building A, in this scenario, let's say this is the building A, in which the distance or the northing and easting, which is NS, is north and south, which is 24,292.7. It means it is at a vertical distance, that is, this is the north-south, of 25 meters from this origin, and at a horizontal distance of 6.5586 meters from in the horizontal distance. So this is the location of this project over here, and any element while constructing over here will be measured from here, not from here. For example, if there is a column over here, or if there is any point over here, if there is any polygon over here, let's say, for example, if I have a column over here. Now, if I need to basically locate this column as a coordinate, so in this situation, let's say if I want to locate the coordinate of this particular entity, it can be anything. Let's say if I'm putting it very small. So if I want to locate this in the site, so here what I'm going to do is, I'm not going to basically take the coordinates of this particular reference from here. Now I'm going to take the reference from this particular point. Now here in the annotate of Revit, while we are annotating, there is something called spot coordinates. The moment if I click here, you find that the spot coordinate is 3733. Now, this is the value over here. Now, if I want to basically take this from, let's say, the project base point. Now, this coordinate base is from the survey point. I can change it from the project base point. Now you can see that the coordinate of this particular column inside the project is 64405747. That means the corner of this column or any entity is at a distance of. Similarly, if you have any other element over here, let's say I put another object over here. So this would be, let's say, again, I go to the annotate, I take the spot coordinate, I can take the spot coordinate here. Now, in site, actually, whenever we are locating the XY or the coordinates, we always take it from the local benchmark. So this is a local benchmark of the site, and here this is the benchmark. That means the benchmark for the entire site. For example, if I want to take the coordinate of this, now over here, let's say, if I take the coordinate of this particular point, this is 0, 0. But here I want to mark it with reference to this particular point. So what I can do is I can basically change this and make the values over here. Now there is no elevation over here. So we will see about what the elevation, how can we mark it. But currently, this particular point, which is the local base point or the project base point, is at 24,293 millimeters from the site. So this is what exactly is the survey point. Similarly, every point, let's say you have to have, for every project, you need to have a local point. Let's say this is the project base point for this particular site. This is the project base point for this particular site. This is the project base point for this particular site. So there are 4 sites or 4 projects which are having different base point whose coordinates are like this. Now you have now settled down the coordinates, that is X and Y, and anything which will be done inside the model will be checked from the local project base point. I hope you have clarity regarding what is the how do we have the surveying done inside a site. Now the next part is the elevation. Now what is elevation? So when we see, the elevation can be seen here in the in the in the in the I mean, all the elevation can be seen in the elevation heading over here. So I have taken the north elevation. Now I can see that in the level, let's say I can mark it as AEGL, that is average existing ground level. So I say yes. Now over here, if I mark this as AEGL, now let us put now over here in the site plan, you can see that the markers are available. But in the elevation, the markers are not available. So if you want to see the markers, both the survey point as well as the project base point, it is preferred that you should type the VG key to invoke the visibility graphics override for elevation. Now, what is a VG key? So VG is visibility or graphics override. You can get this dialog box from the view tab, and from here you can have the visibility or graphics and click it, and you get this visibility or graphics override for north elevation. And here you can basically check the site over here and put the project base point and survey point both on. Now you can see here the project base point and the survey point are seen over here. Now what we need to do is I need to have the elevation of this AEGL with respect. So this is the 0 from where the true elevation or the sea level is measured. Actually, this AEGL is at in our side is 80. Let's say if I take it here, it's 62 meters. Let's say this is 62 meters because I've changed it. Here the elevation has changed. So you can see that as I am zooming in. So let's take the elevation as 44 meters, let's say. So this is the 44 meter data, which is I'm getting from the Google map. So if I want to change the elevation, I want to make this as 44 meters, that is above the survey level. So your project base point height should be, the elevation should be from the survey point, which is 44 meters. Now, how do you do? Many people do it from elevation, but it is not correlating with the survey. There is a tool over here in Revit, which enables you to get the, so you go here in the manage. So here you find that there is something called relocate project. So how do you get in the manage? There is a drop down here and say relocate project. Now, the moment you relocate the project, you can select the AE, this one. This is the base point over here. And then now you can look into it, click it, and then move it above. Let's say you can move it at 64 meters. Let's say, what is the distance that we have? It's 44 meters. So you can say it, let's do it again. So you have the relocate option here and just click it here and say 44 meter. Now what will happen? Your project base point will change. Now still you can see that your project base point is 0 because in the level style, in the edit type, you have the elevation base as project base point. Now you can change the elevation as survey point over here. You can see all the data will be seen from the AEGL. Anju, is it exactly what you were trying to say?
Yes, Manas.
Right.
You're right.
So now we have set the site with 3 things. Now, first we have set the project base point. We have set the site base point. Now you have got an elevation, which is basically with the 44 meters, which is saying now the site is ready for the design. Now, other thing that is a true north and the project north, what Anju was saying. To make it clear what is the true north and project north, let's take this example from the Google map. Let's say this is a building pad, or this is a building that we need to develop. Now here, let's take an example. So what I can do is I can use a snipping tool here. Right? And take a capture of this particular place and save this to find out what is a true north and what is a actual north. So we'll talk about, so I take this capture over here from the snipping tool, and I can bring this particular image here at a different scale or whatever it is. I'm not scaling it right now. So what I can do, insert, import image, and here I have this file that I can look into it. Let me see what is the name of the file. I have to change the name of the file again. So let me go with the snipping tool again. So I have to save it, file, save as, and save this as a JPG file and name it as NITTR campus, let's say. So I just put it over here, and so this is a capture that I have. Okay, fine. And here in this capture, let us put this image over here. Now, why I'm putting this image over here? Because I am wanted to understand what is a true north and what is the project north. Now, let's say this is the building that I am having. So here, if I sketch a line over here, let's say this line is a vertical line, which is the true north. This is the true north. But if this is the front of the building, this is the south and this is the north. So in this case, my true north will be exactly in align with this. So this is the, let's say this is something that I want to build. Now here, the orientation of the building. So this is the direction of the project north and this is the direction of the true north. Now the orientation of the building is the true north is at an angle with the project north, which is like this. So if you have an angular dimension, now this is it's 35 degree from the true north. That means towards the west. That is the value. Now, how do you do that? Again, what Anju was saying about it. So when you have this, let's say if you want to orient this site or the project over here in Revit, let's say I go here and let me open the file that I was working in. So here, if you select this particular, so you have this angle to true north. So either what you can do is you can align the project north. Like for example, you have this value, you can bring this, both of them, let's say. So I'm selecting both of them. I'll just finish up the session because we are getting late probably, but just give me 5 minutes time so that we can wrap it up. So I just move this particular part and bring it somewhere here, let's say, so that I can align this section with this. So this is exactly what I wanted to do. So this is my true north. So if I select it, currently my project north is aligned to true north. So what I can do is I can go here and say rotate project north, and I have an option of selected line or plane. So I can select this line. I can see that my project north has changed. Now here you can see that my project north is 325 degrees. So it has gone aligned it. And now what I can do is if I change the orientation to true north, you can see that my site is oriented. Now this is the true north. Now you can see that my site is oriented at that angle that I wanted to have. So Anju, that was my part. And what will happen? So I will continue after the break about the shadow analysis and the site integration and the multi-discipline. So you want to finish the session, Anju? I just wanted to help you in order to, with what you were trying to say. Up to you.
Thank you so much, Manas, for explaining it in a wider frame. And I hope the participants has now understand what is the geolocation in the Revit and how we can geolocate the.
Yeah, some questions are there. Yeah, Mr. Sumi, you can come and please ask a question. You're not audible, sir. Okay. Anju ma'am, you can continue, please.
Okay, so I think now the participants understand that how the, I hope, I know that it was a very long and very quick demonstration of Revit, but now they understand that how Revit works and what is the what are how we can model in the Revit, and then definitely in a wider frame that we they just learned about the how to place the Revit model according to the geolocation, and then I hope in the next sessions they will come to know that whatever the building which we have created, that building can be analyzed, and then it is how this BIM model is can be analyzed for different purposes, and then definitely for they can visualize. They can use it for visualization, rendering, and all that, and also for multidisciplinary coordination.
Thank you, Anju ma'am. I think we need to go for a break, and
Yeah, thank you, ma'am. Thank you so much for a detailed description of the entire steps and the process involved in the Revit program. Of course, I think this yesterday you had been and you have given very detailed description of it. And I hope all the participants they must have understood the steps. Of course, it needs time to be put in order to be sort of on Revit on this software. So what I believe, if the steps are clear and if they keep on working on it, they'll be getting that experience for which they'll be proficient in handling this. Thank you, madam. Thank you once again for a very great, informative and interactive session for these 2 days. Thank you once again. And Mr. Krishnan, thank you also for being a moderator and giving all the inputs. Those are required at different points. I believe after lunch it is going to be you for both the sessions.
yeah.
Okay. So okay, we break for lunch and we meet again at 2:30.
Sure, sure.
Thank you. Thank you.
Thank you, sir. Thank you, everyone.
Muy bien, por muy bien, 이기와데 리딩 디디메쇼 인가만에 마타고라나게나 리딩도 삼대나 삼삼대 전나라기 보이나 할머니인데 가루래 리딩도 리딩 로전 그 그것도 계시대
저 보시거든. 그때는 그래도 이거는
Good afternoon, all. Am I audible?
Yeah, Manaji, good afternoon. Yeah, you're audible.
I'm sorry, I've got 2-3 minutes technical glitch thi koi.
No issues, no issues, no issues.
Right. So it's I think it's all good to start.
I think we have 35 already connected. You can start on the session, no issues.
Okay.
Manaji,
Thank-
एक थोड़ा सा करिएगा that you can continue the session up to 3:30 instead of 3. And
Perfect.
then you give a break of half an hour, and then next session you can take from 4 to 5.
Amazing. Amazing. So I can continue for an hour.
Yeah. I think that will be better.
Okay. Okay. So Dr. Sood, I just wanted to brief what exactly I'm going to take from now.
Please.
So I think a lot of students may be interacting with me. I mean, as a speaker now for the first time, just wanted to set the stage and just recap of what we have done in the past 3 days, in fact. Today is the 4th day, in fact. And we started up with the geospatial part of the digital construction, and we had sessions from ISRI. It was a wonderful session. The idea of geospatial connect with the BIM was in order to understand about the data and how important is data today in construction industry, because we are into a data driven ecosystem currently, and digital data has become a very predominant feature of any business or enterprise. So that was the main thing, is to how to connect with the geospatial data in construction. In which phase this data will work, I will just take care of the project life cycle from the point of view of a digital construction. So my role here from now would be in order to let the knowledge that has been spread in the last 3.5 days, and move and traverse towards a better understanding of building information modeling through software, through knowledge, and through understanding of the metrics of what building information model or a digital construction requires. So I would be using Revit also, because Revit is a platform. I'll tell you, it's an authoring platform like ArchiCAD, Revit. And so we will now be understanding about what we have learned in Revit. What Anju was doing is in order to give a brief showcase about how a building information modeling software works. Now, what you have learned in the last 1.5 days from Anju may be predominantly how to start a project, how to use an authoring software to create a 3D data-rich model. Why I'm saying data-rich model? Because the model that you had created is not only for 3D visualization, but it has a lot of data that can be put into for various kind of value engineering or for various kind of data interpretation. Now, what is data interpretation? What is value engineering? We will come to it. But very important term that we are going to learn today is about a common data environment. And that is the reason why basically, due to the common data environment and due to the integrated project delivery, BIM is getting so predominantly used across the industry. Now, when we say BIM, it may not be a software. Now, a very important part is, I just wanted to break the myth. BIM is not a software. BIM is a process by which we achieve digital data for a construction process, and all are connected. All stakeholders are connected through a common data environment. So what is the takeaway with GIS or BIM learning is, whatever we have learned, this is not a software. This is a process to achieve the a process to achieve a common data environment in which we can work as a unified stakeholder in the process of construction, whether it is a bridge, whether it is a railway project, whether it is a ceiling project, whether any kind of construction project, whether greenfield project or a brownfield project or whatever type of project is, the data in the digital construction is very, very important. So we say that in BIM, I is very important. So my session today, in the next 1 hour, Dr. Sood was very generous enough to give me 1 hour, at least for this, would be in order to make you understand. I'll just break from Revit now, because then in the next session, I can, for the 1 hour, I can talk about how the multidisciplinary can be worked in Revit, and in softwares like Navisworks, how do we pull the data into a common data environment? How do we perform clash detection? How can a 4D or a 5D simulation can be achieved? How a digital review can be done? And there are a lot of things that we can learn today and tomorrow. We have got ample room. But the first question should be asked, what is the process in achieving an integrated project delivery in a ecosystem of BIM? Now, with this, very important part is for every process that we do, there is a compliance which is attached to it. Similarly, for BIM and GIS or any digital delivery of project, there is a compliance that rules in order to how, why, and where, and when to do what. And that compliance is called BIM standard. So today we'll also learn about the standard as ISO 196 out how to achieve a common data environment irrespective of naming any software, though software is an integral part of the technology process. But very important in achieving a common data environment is to reshape and rebuild the way we work. With this, thank you once again for being with us for the last 3.5 days. And my name is Manas. I like to introduce yourself. And when we started up this program, we had in mind in order to educate our today's entrepreneurs, the teachers, educator about to break the myth of what BIM is, to learn something about BIM, what BIM is, and to take this knowledge and spread across our ecosystem. Thank you so much, Dr. Sood. You can start recording if you have not.
We are already
there are. Yes, sir. Thank you, sir. What you're saying, sir?
Please carry on, Mr. Manas.
Yeah, thank you, sir. So there would be 3 things that I will be covering in this 1 hour or extended session. One is regarding this this particular part as the integrated project delivery life cycle, which is a BIM solution, what it is. Then I will be delving with what is common data environment, precisely what does a common data environment means, what are the structure of a common data environment is. It's a bit of theoretical subject area, but it is also very important for a framework for a process like building information module. Now, then we will also be learning, we will also be going through a presentation for construction cloud. Now CDE is a concept, but in which basically complies with a standard, which is ISO 19650. So the solution is Autodesk Construction Cloud. Now, what is a construction cloud? How to basically use the construction cloud is how Revit and other softwares are basically connected with the construction cloud. We will have a brief introduction about it, to know it. And then later on, by use cases, probably tomorrow in the next session, we can show you use cases of how you can use a construction cloud and what is the benefit of using the construction cloud. So that's what is the agenda set for the day, at least for the first session or extended session. And then I will be talking about, again, go to the Revit where Anju has ended, talking about the scope of working in an architectural model. In a conceptual stage, she talked about how to build a model which comprises of digital data like creating walls, creating doors, windows, and there are several tools that has been discussed. My role would be in order to integrate the BIM process inside the learning that Anju has provided you so that you can understand from a BIM point of view how this data can be used, can be applied, and can be achieved for the goal of building information model. So that's what is the agenda set for the day. Now, to begin with, the first thing that what we need to understand from this particular slide is we hear this word called IPD. So IPD is a term that is mainly used for the delivery of a project. Like as the name suggests, IPD is integrated project delivery. That means you have an ecosystem where you are integrating all areas of your construction, putting all the data into the digital platform, and then you collaborate and coordinate with the stakeholders during the life cycle of the project. So what is the life cycle of the project? We will understand in the next slide. Now, there's a brief introduction about Autodesk. So before that, let's understand about what is BIM again, because we need to have a definition. We are talking about smart cities, how BIM is helping in developing smart cities. So smart cities will be developed with smart buildings, with smart contracts, with all Industry 4.0 technology, including artificial intelligence, including blockchain, including all the technologies, the cloud computing, everything has to be integrated to build a smart building. And smart cities can be built if you have smart buildings, if you have digital twins. So digital twin is one of the solution for the smart cities. So what is a digital twin? We will talk about. But before that, to the micro level of understanding to the buildings, how do they operate in a digital space, we need to understand the definition of what is BIM. Now, building information modeling is an holistic approach for creating and managing information for a built asset. BIM integrates structured multidisciplinary data to produce an intelligent 3D digital model to project of a project across its project life cycle. So here we have two bold words or phrase that is coming. First, you can see in the bold is the holistic process. And the second one is an intelligent 3D digital model. Now let's dissect it and understand what is holistic project. So when we talk about a holistic project, it does not restrict to a holistic process, does not restrict to only creating the model. It basically a process that involves in entire life cycle of the building. It involves everything starting from data collection to data collaboration to data capture to data execution, everything from start to end, cradle to birth to cradle to grave. All the solutions in the construction is taken place through a digital model that basically the BIM
Manaji, you're not audible.
What building I am? Anybody can come ask you. What does
Yeah.
building in building information modeling
For a while
mean?
in between.
Sir,
You're not audible in between.
voice is not audible, sir, properly.
Anyone? I cannot hear
Mr.
you.
Manas, you were not audible
Pardon?
for a while.
It's not audible.
You were not audible.
Am I audible now, sir?
Now it is okay. Now
Am
it's
I
okay.
audible now?
Now it is okay. Yeah.
Yeah, you let me know if whether my internet is switching down or on, right? I
Yeah,
can.
yeah.
I'm not sure
We did
about.
try to connect you.
I'm very
we
sorry.
did try to connect with you, but you're not able to do that.
Okay, I'm very sorry, sir.
No, no
For
issues. No
inconvenience.
issues. That was no issues. No issues.
So is my screen visible now, sir?
Yeah. Screen is okay.
Let me change my internet connection so that I think it may
Yeah,
be.
you can try that.
Visible now, sir?
You're audible, but your screen is not visible.
Okay. Now is a sound is
Yeah. Otherwise, you're audible. The screen is not visible.
proper? Sound proper now?
Sound, yeah. For the present,
Okay,
it's okay. Yeah.
Okay. Thank you, sir.
Okay.
Let me know. I'll just repeat the question and let me know about if it is audible. Now my screen is visible.
Yeah, it's okay
Is my-
now. Okay.
Okay. So I was talking about the could you hear the definition of BIM that I was talking about, sir?
We got stuck up at that holistic process you were talking about.
Okay. So the holistic process. Now this holistic process is the term that is used in the process of the life cycle of the project. Now, what is the life cycle of the project? From cradle to grave, from birth to death of a project, BIM takes care, BIM is in action. That means in a process from planning stage to handover stage to the facility stage, everywhere the BIM is applicable. So you are creating the information as the project matures from cradle to grave. That means from planning to design, design to build to operate. In every process, the BIM is integrated and the data is integrated. Now my question is, where I think I was frozen is, I just wanted to ask any of the participant, what does building means in building information modeling? Just anyone can come so that the myth can be broken.
Sir, building here, it stands for the work part that we are building, creating.
Akash sir, I think you are right, but I think most of the people has a very different idea of the BIM. So here building is, as Akash sir said, it is building the information inside the model. That means at the very conceptual stage, when you start planning the building, there are data which are basically in very raw form. And that when you start the process from planning to design, data becomes rich. So we'll talk about what is the life cycle of the project. And so it says that the BIM integrates structured multidisciplinary data to produce an intelligent 3D digital model. Now, here, the intelligent 3D digital model means a model that reacts to the change. The model is intelligent enough to change as per the changes which is there in the ecosystem. So it is not a dead model. It is intelligent enough to get into the change in the aspect of the process. So when we say an intelligent design digital model is, let's say, if the height of the wall changes, the area of the wall changes. With area of the wall changes, the volume of a room changes. With the volume of the room changes, the lighting requirement of the room changes. With the lighting requirement of the room change, the energy requirement is changed. With the energy requirement of the change, the carbon demand changes. So you see, so much things are interrelated to each other. If you change the height of the wall, it is not only changing the sections and elevations, and it entirely affects the entire process of the building. So it is very dominant that a model that is capable of understanding the ecosystem of the process should be an intelligent 3D digital model. So whenever you think of changing the thickness of the wall, remember that with this, your air conditioning requirement will change, because with the thickness of the wall, the thermal efficacy of the wall changes. The U and R factor of the wall changes. With this, your heating requirement may change inside a space or within the space. So everything is connected. In design, everything is connected. And let's say if you talk about the BOQ, your tender requirement will change, your estimate will change. So there are so much change that happens due to one change. So every object will be interconnected with each other if a change is there. And it is only possible if your model is an intelligent 3D digital model. I hope I am able to make you understand what we are moving ahead of understanding BIM. Right? Now, next part is BIM is the foundation of digital transformation. So here you can see that in this particular flow chart, where we have the 4 stages of a project, which says plan, design, build, and operate. So within these 4 stages, the project lifecycle acts. So it says that BIM is the foundation of digital transformation process, which empowers seamless collaboration, decision making, and better outcomes for all stakeholders, and built on a connected data experience. That means even a mason who is working on the site should be connected to the BIM environment. The site engineers should be connected to the BIM environment. The project engineers are connected. So it is not that the BIM is restricted inside a design room. The BIM objective is to go inside the site and correlate and coordinate in the site to each and every people who are working in the connected environment. With this, let us understand the various phases of the BIM life cycle. First is the planning phase. So in this planning phase, the moment in the slide, you can see that the digital twin starts after the build is done. That means during the process, you're also developing a digital twin together. Now, what is a digital twin? The word that we have heard in many seminars or many papers or research papers. So digital twin is not anything new, but a BIM connected environment with the site. So we will talk about what is a digital twin is all about. But here you can see you're developing a digital twin as you go towards the life cycle during operation phase. Now, planning phase has 3 or 4 subcategories. One is the capital planning. Second is the existing condition collection. third is the basis of design and baseline of cost and schedules. Now, this is very important. Now, what you have learned in the section where you talked in the GIS integration, these things, existing condition collection, capital planning or budgetary, and the basis of design, the environmental basis of design, the geotechnical basis of design, the ecosystems, everything is based on the planning, and then you have the baseline of cost and schedules. So again, in this case, when you have a basis of design, you can use, now it's important what technology you have to use in order to integrate your data into a common data environment. So we'll talk about in length and breadth. Now, the next is the design phase, which comprises of the conceptual modeling that you have learned early in this phase with Anju. She was talking about the conceptual design. Now, the design phase has got 4 subphases, which is the conceptual phase, preliminary phase, detail phase, and the final phase. That means here at this stage, the architects, engineers, collaborators, like the MEP consultant, everybody is collaborating into a design that is basically has to be built on the site. So here, what is the effort that you are putting as per the technology is concerned and as per the role of the entire design phase? 10% is basically of the conceptual phase, 30% is in the preliminary design, detailed design is 60%, and the final design is 100%, which goes to the build. Next, in the build also, you have got three phases. One is the pre-construction phases, one is the construction phases, and the other is the commission and handover. So in the pre-construction phase, before you build, you have got different kind of coordination and collaboration between the contractors and the designers. So you have got, this is a pre-bid stage where basically you have all the data, you do the clash detection, you do the time analysis, schedule analysis, you do the cost analysis, every kind of things that is basically required for a pre-construction stage begins over here. And then comes the construction stage, and at last you have the commissioning and handover. And the operation phase consists of 2 subphases, which is the operation and maintenance. Operation is the operation of the machines, operations of the built environment, operations of the equipment. Operation is very, very important part of the O&M or the facilities, as well as for the maintenance of the equipment, maintenance of the site. These two they make together and make as O&M or facilities management. Now, here comes the thing. I'll just move this and hide it for a while. So here it says that from capital planning to maintenance to the final stage where we have plan, design, build, and operate. You have got the first line is what are the tasks that you do over here, and then what are the tasks that you do from which phase to which phase, and this is the task that you do in the later phase. So the content management, collaboration, workflow automation, project control and compliances, these things are done throughout the planning to operate phase. Now here comes the common data environment in which one have to work. So this entire is in the common data environment that you are supposed to work. So here from content management comes from the common data environment. Collaboration comes from the content common data environment where you collaborate with different stakeholders. Workflow automation, project controls and compliances, everything is a part of a common data environment. But here comes the software where you basically capture the data, create the data. So data capture is from the basis of design to the pre-construction phase. So here, during this, you use different kinds of softwares like Revit, ArchiCAD, and various other BIM softwares to capture the data in digital format. But most of the work that in the BIM that we do is in the common data environment, when you collaborate different types of data, where you automate the workflow of the construction, where you control the project and the compliances requirement. These all are inside the common data environment. And then you have the data capture, and then you have the visualization, analysis, and optimization, which is from the baseline cost and schedule, which start from the planning phase, which is basically 4D, 5D, or project management scheduling, whatever you do. And then with 3D, VR, AR, you have the visualization, optimization of data through various analysis software, and there are a lot of things that you can add into it. So I'll not go with this particular data. Benefits of BIM we already have done. Now, first thing that we need to understand with some use cases where the common data environment has been used. Let us take an example of the project which is of transportation and road, which is a road or railway. Now, what we have done is we have basically created all the three phases, and we have made some software integration over here in which how the BIM is basically working. Now, if you look into the planning phase, you have feasibility studies, you have alternative analysis, you have existing condition modeling. So here the integration of Esri GIS data from ArcGIS, this is an Autodesk Autodesk platform we are talking about. So these softwares are all Autodesk softwares in which Autodesk InfraWorks, Autodesk Civil 3D, and then you have Recap Pro. These are all of the planning phase, where basically the planning phase consists of the feasibility study, alternative analysis, existing condition modeling, preliminary road model, preliminary civil structure model. This was a road and rail project that we are talking about. So here you can see that at the bottom, there's a delivery project platform, which is a common data environment, because from the very start to end, this common data environment works. So here you have got document management, multidiscipline collaboration, and model coordination. These are some of the functions of the common data environment. Now, the moment you go to Revit, we are talking about road or rails. Then you have softwares for the roads and rail is the Civil 3D that we work for roads and rail. Geotechnical model we use Civil 3D. When we talk about structural model like tunnel bridges, we use Revit, we use Recap Pro, we use Civil 3D, and for hydraulic design, we have InfraWorks and utility design. This is for Autodesk solution that we have. So these are some of the tools that is achieved during the design process of the BIM integrated project delivery. So this is an integrated life cycle part. In the pre-construction, there are a lot of clash detection that has to be made. Like, for example, Navisworks that we have for clash detection, 4D simulation, where we simulate between the project schedules and the project model. So model walkthrough through Navisworks and visualization. So you can see that for every stage of this road and rail project, we have some tools that have been achieved over here. Again, these models are again collaborated through a common data environment. Then in the constructions where we have digital RFIs and 2D and 3D takeoff, quality, safety management, and cost management, and project closeout, these are all through Autodesk Build. That is again a common data environment software through which you use it for delivery of data and basically exchange of data along with Esri GIS software in which you integrate it. And at last, you have an operation maintenance where you use Autodesk platform, as well as for digital twin, you use Autodesk Tandem. So this is one of the framework that I wanted to make sure that you understand about what is the role of BIM in software in BIM to achieve the project life cycle. Now, next is, again, you can see that this is a detail of it. So the planning stage, the design stage, the pre-construction and the construction and the operation phase. Now, during the planning phase, I'm talking about the rail and road project, then we'll be going towards different types of project, then we will understand about. Now, in this phase, the phase involves the initial assessment and conceptualization of transportation project, including site, road or rail, bridge, tunnel, stations, terminal, drainage, flood. It includes site analysis, feasibility studies, preliminary planning and estimate. Autodesk InfraWorks, which is an Autodesk platform. We are talking about Autodesk platform. AutoCAD Civil 3D, Autodesk Recap Pro. Recap Pro is for the data encapsulation. So you have got data which are captured as point cloud data from drones. Recap Pro does, I'll show you some examples what Recap Pro do. They basically get all the data from the point cloud data with RCP or RCS file, and they integrate inside the software in which you can see or visualize the current asset or the current site conditions into a 3D photogrammetry kind of situation. So third-party integration with Autodesk. So Esri has a very good integration with Autodesk, in which all the data that are captured through Esri softwares in the planning phase are basically delivered into InfraWorks and Civil 3D in Autodesk. In the design phase, we use a lot of softwares. We are learning Revit as a preliminary software in this session, in this course, in which we are trying to understand about the integration of geospatial and BIM through Autodesk software. So Autodesk InfraWorks, AutoCAD Civil 3D, Robo Structure Analysis. Now, there might be a lot of civil engineers who used STAAD Pro or ETABS. Robo is also a part, is like a FEA softwares like ANSYS, or which does structural analysis of buildings. So I'll show you some demonstration of how an Revit model can be brought into a software, or how can it be interoperated into structural analysis, and how the data can be kicked back to Revit. All the structural analysis data can be kicked back into Revit by use of Robo Structural Analysis. Then you have InfraWorks ICM, which is for the civil works, and BIM Collaborate Pro, which is the Autodesk 360. So these are the software that can be used for the rail or transportation project. Then for the pre-construction project, this phase focuses on planning and aligning the project before actual construction bit. It involves activities like clash detection, walkthroughs and visualization, schedule-based 4D simulation, etc. So you have softwares again with Autodesk Navisworks. Now you create the model in Revit, you create the model in AutoCAD Civil 3D. Now you need to basically go and visualize the project before it is constructed. So here comes Twinmotion, here comes InfraWorks, here comes Navisworks, through which you can visualize the entire project. You can do 4D simulation, you can do walkthrough, you can do the clash detection by bringing all the design into a integrated environment, which is basically through IFC export, or there are different things that I will talk about when I will take a session of Navisworks. How does it work? Then come the construction phase. It's a very important phase, because after planning, design, pre-construction, now you're in the construction phase. The project is brought to life by integrating the design office with the site office through digital workflows, manage site quality, safety, logistic planning, cost scheduling, and project closeout. So here we have third-party integration along with Esri with Autodesk InfraWorks and AutoCAD Civil 3D, as well as Autodesk Build. And last is the Autodesk Tandem, is a software which is used for digital twin. Now, digital twin is an IoT which is connected, Internet of Things, connected through, let's say your machine is operating in a particular site. Through your IoT devices, the machine is connected with the digital model in the cloud, and it is basically pouring data into the cloud, everyday data, let's say in operation efficiencies or loading of the machines and breakdowns of the machine. All the data are connected with the digital data, and the digital data is processing those data, and through artificial intelligence it can predict can make a maintenance plan or can predict a lot of things. And that's where the digital twin is there. When your digital model is connected with the real model, then the digital twin kicks off. So this is for the operations. Digital twin is the reality in operations. So here was a brief detail of so there are some case studies. I would, let me take another example of a building. So I'll just take, if I do have, so you can see that how the mechanical and GIS building. Now, in case of buildings, again, the first example was from the railway or road projects. Now, from the buildings, what we have learned in the planning stage, we have traditional survey data or a modern survey data. Now, through Autodesk Recap Pro, you get the data, the cloud data, the site survey data, and bring it to the software, which is Recap Pro, which you can use photogrammetry as well as point cloud integration into the site survey. Then you have the site analysis, which you can do either in format or in Civil 3D, where you can do a lot of analysis like watershed analysis, runoff analysis, and a lot of surface analysis. You can do the entire contour study and planning, massing, and analysis and conceptual modeling in Autodesk Forma. And also you can do the same thing in Revit. Next come the design. Entire design can be done in Revit. Entire documentation can be done in Revit. Quantity, scheduling, and takeoff can be done in Revit, that we have learned. Clash detection can be done in Navisworks, and visualization, that is the virtual reality or real-time visualization, can be done in Twinmotion. So what we have learned over here in the last 3.5 days is regarding the project of building, in which we have learned about the GIS, we have learned about the design, modeling, and coordination in Revit, and design documentation, and how the scheduling and estimation can be done, how the clash detection, we will learn about how the clash detection works. Probably tomorrow we'll have a session on the clash detection and visualization. And after that, when it goes to the construction phase, everything is placed on Autodesk Platform Services, which is a common data environment, in which you have a digital RFI, which you have submittals, photo, change order, quality safety management, cost management, project closeout. And then again, through the common data environment, it is handed over to the operations. And here we have the digital twin building, model and visualization through Autodesk Revit Pro and desktop Autodesk Docs and Tandem Connect. So this is how the entire ecosystem works. Now let's quickly go through the project lifecycle stages, and then I will come to the definition of common data environment. What does it mean? So any questions anybody has before I close this session in next 15 minutes, I will be able to take after the finish of this slide. Now, when you start with the planning stage, the initial planning stage of a building basically involves critical activities that lay the groundwork of the project. So it starts with the site analysis, which includes surveying. Now, traditional surveys are basically changing now. Now, most of the surveys are done through GIS, GPS, or through total station or robotic total station or drones. Most of the surveys are now done through drones or TS, which are robotic total stations. Now, including environmental assessment and regulatory reviews. This is followed by site contextualization, focusing on visual aspect to ensure the design integrate well with its surrounding, that we talked about in the previous discussions. Conceptual planning involves developing the project vision, preliminary sketches, and feasibility studies. Early stage planning analyze the assessment of the site, constraints, and opportunities to optimize design output. Finally, the site is functionally zoned with careful planning of circulation and space allocation. Now, here in the planning stage, what we can visualize is what are the things that we do. We do the environmental analysis, we do the site feasibility analysis, we do the shadow analysis, we do the energy analysis, everything that is related before the design starts. Now, who does it? The environmental planner, the architects, the landscape designers, the stakeholders, maybe the energy consultants. They come and do all the stages of the planning along with the architect. Now, what is the software that can be used in Autodesk domain? It's Recap Pro, Autodesk Informa, Format, InfraWorks, Civil 3D, and Autodesk Docs. So here we can also use Revit as a conceptual modeling stage. Most of the projects at the conceptual stage can be worked out in Revit or in Autodesk Forma for buildings. Now in the design stage, basically, we use softwares like the Revit or the Navisworks or the Collaborate Pro, which is the Autodesk Cloud that we are talking about, in which the collaboration between the various designers and the consultants starts working. So I'll talk about what is Autodesk Construction Cloud, because most of the common data environment of the BIM is oriented or surrounded across the Autodesk Construction Cloud, along with the learning of the software like Revit and Navisworks and different others. So during the construction, so here you have the design stage of a building involves integrating all architectural, structural, and MEP elements through comprehensive modeling and coordination. Now, I probably, after this session, I would be showing you how MEP models can be built, how the structural model can be built, and how can they be integrated inside the software, and then how the common data environment will work. And we can see, if time permits, we can see how this can be taken into Navisworks. So advanced, now when you have the MEP model, which is connected with the architectural model and the structural model, after revisions or after reviewing, you can see that what is the current stage of the clashes, right? So you can do the takeoffs also, you can have a precise quantity takeoffs, you can have accurate scheduling, and you can have accurate cost estimates. Advanced clash detection is used to identify and resolve potential conflicts, ensuring a smooth construction process. The 3D renders are the same, are created in order to have a better visibility for the design project. So this is for the design phase. But when you go to the construction phase, and before, when you are constructing, pre-construction, you can do the clash detection and other thing. But in the construction phase, you have to integrate all your design and work with the contractors and in the site who are involved. And it is done through Autodesk Build, which is again a cloud-based solution from Autodesk. So we are talking about Autodesk software, and there might be different other softwares in Bentley or any other platforms. But Autodesk Build is one of the software that is used for ensuring real-time collaboration, ensuring that the project safety, cost, and schedule construction meets standards and is completed on time. The phase concludes with a thorough project closeout process, including final inspection and documentation. At last, once construction is complete, then you can basically hand over to the maintenance team and the operation phase begins. This stage is a building project involves creating a digital twin model. This model integrates real-time data from the IoT sensors embedded through the building, allowing for continuous monitoring and analysis. So this is a short description about the common data environment and its use. So any questions anybody has before 10 minutes I will take in order to talk about the CDE. Any questions? I hope I'm able to make you understand and link your learnings that you had for the last 3 days, 3.5 days, where we are now. Am I audible?
Yeah, you're audible.
Yeah.
Yes, sir.
So any questions, because we have a 5 minutes time before I go through some data sets from ISO standards or a framework of BIM, because this is very important as in the learning of BIM, not only to understand that the BIM is not a software, but it is a process during the life cycle of the project. So any questions that you have regarding any doubt that has been created during my presentation, that this is something I wanted to know. Okay. So how many of you have heard about digital twin before this? Okay. Richa, what digital twin, what did you heard about digital twin, and what is your takeaway with this knowledge of the 3 days, and how you're going to take away, I mean, how you're going to manifest it into a real-time project with this learning as a student of digital twin, or an understanding. Let's say if you're asked to create a process for a digital twin, how will you make a process for creating a digital twin? Anybody can answer this question. Let's say today, if you are asked that this is a project that I want to have, I want to make a digital twin of this project. So how do we start creating a digital twin? Is it a day job, or it is a long time job and a process?
So it's a long process, not a day job.
So Mr. Akash, can you please tell me about how to achieve a digital twin in a project with the learnings that you had till now?
First of all, we have to understand that the digital twin which we are creating for the existing structure. For that, we have to study the structure first, so that the virtual mode of the structure can be created. For that, means we have to look for the every single aspect of the project, like what is the in what area it is built, how many story it is, and what is the functional use of the building. Then what are all the things in the building, like HVAC system, plumbing system, electrical system, all those things. Then what is the alignment of those facilities. Then we have to step by step incorporate in the software, so that it can simulate the same structure. That's it, sir.
Very, very nicely said, Mr. Akash. Anyone basically can put a light into it to carry it more, more descriptive about how to achieve a digital twin. Let's say today we are talking about digital twin, we are talking about efficiency, we know about the value of it, but how do we achieve a digital twin? Is it that by creating a 3D model we are going to achieve a digital twin, or we can achieve it at any phase of the building, I mean project life cycle?
So first we need to have information models, and by information model I mean, so say if we are talking about a building, so we should know all the characteristics of the building, and then what processes operate in the building and how it is going to be used. So operations. And then we try to add, try to get real-time data on operations and usage to understand and predict the utilization of different not just the spaces, the areas, but also how we can improve the efficiency of the resources that is being used in the building, and then also like how to make it more efficient towards life as and when we go along. So it is not just building something, but it is also operating and then managing and predicting towards better utilization of resources.
Okay, ma'am, I just wanted to know what is your core area of specialization you're working, so that we can brainstorm more about it.
Transport.
Transportation. So let's talk about a rapid transport system, right? So if I want to create a digital twin of a rapid transport system, right, what are the main data sets that I can connect? Give any example from a transportation system where we will benefit, and how digital twin, how data can be connected through, what type of data has to be fed. Let's say very basic preliminary data that we are talking about, right? From a railway point of view, because from a transportation point of view, there might be many data, like signaling data can be there, right? There may be networking data can be there. There are a lot of data that come. Now, give five things that come into your mind that can be integrated into a model to create a digital twin. We are just brainstorming, ma'am, that
Right.
people can understand.
Say we talk about BRT systems, and or we talk about bus transport systems. So say the first data set that will go into digital model will be the road infrastructure, different signal signages, all of that. Then we add what routes, so what kind of vehicles, what kind of routes they're operating on, and then we can use GPS data to take a routine real-time log of the location that comes in the operations part. And then we can integrate it with the resources that are being used to operate those vehicles. So say we need some bus drivers or conductors to like operate, so that also can be added to the routes, and then it can be scheduled as per the requirement. So that is one. What else? So we can add signal timings. We can calculate delays. We can calculate if there is some deviation in the route, or if there is some deviation in the travel time because of any other external factors. If we have a digital twin, so then all the travel time characteristics we can calculate based on the real-time information that we're getting on a digital twin console, sort of.
So then what is the benefit out of it to get that data? What type of technology can we impose into it for better productivity of the system?
So GIS. So if we put it all on GIS and we integrate, like we were having some sessions previously, it will help us improving the not just improving the efficiency of the system, but also scheduling and automating the processes. So for example, I have 5 routes, and on the 5 routes I'm able to track GPS on the digital twin along with the digital infrastructure that we have in the city. Say we take example of Chandigarh, where we have these facilities available. Now say we have a digital twin for Chandigarh, in which we are able to track all the buses with their GPS trajectories, and we have the signaling systems on the digital twin. We have the traffic characteristics on the digital twin by predictive models, if we already have, or we can build those, and we have digital infrastructure. So then we know that if there are some routes that need to be like we do not need, eventually we will not need to have too much manual interventions into scheduling, into designing routes, into designating which places we have more demand. Because if we already have like ticketing data, if we already have where is the demand, where buses are having problems, where are they stopping through GPS data. If we can track all of that digitally and then predict those models, then all of these systems can be optimized by using AI models without having manual interventions of scheduling. This is my little understanding of digital twins.
Okay. Now with the GIS and BIM, the same thing can be integrated into a common data environment. That's exactly what we are learning. Thank you, Richa. I think moreover what Richa has said is about the same thing that we are talking about. She's talking about an AI model. So we are talking about AR model or a digital model, the information model, whether you created any software. So it is not only into the viaducts or the routing system. It can be maintenance of the railway stations, operations of the machines, and there are various things that comes with the built asset, right? So now, so there are so many advantages. Anyone can we can have more 5 minutes to have a discussion about what is the understanding of it and from a different aspect of engineering. Anybody can come. Thank you, Richard, for a clear understanding. Anyone can volunteer. So
I can chip in for another example.
Yes.
Say industries. So we also work on industries. Say big chemical plants we want to, in which there is very little human intervention and a lot of data is already coming on the control system. So if we have a digital twin of such systems, then the control system need not be inside the plant. That is one. And if we have predictive mechanisms like digital twins can integrate the sensing data that we are already having from the control systems in the process plant. So say, for example, Bhopal gas plant that is very famous for the accident. So that kind of a plant we have, and all the things, all the
where hazardous, where it is hazardous to have, human intervention. There,
yes,
you are saying that it can automate the process, and a lot of AI tools can be there to basically predict any hazards if there is going to come, right?
absolutely.
That's what you're saying.
Like sir, while rigs, sir.
Right.
Yes, sir.
Right. So it's same as in the buildings also, like for the fires or any kind of short circuiting or any kind of leakages. So I think that tremendous potential is there with the digital construction today. I think all of us are in sync with what we have done in the 3.5 days, and I think really I'm very much happy that this learning is going more and more towards understanding of how we are changing our infrastructure. With this, I'll just come back at 4 o'clock and talk about common data environment, show you softwares like Navisworks, and can have more discussions about it. Thank you, Dr. Sood. Is it fine?
Yeah, it's perfectly okay, Mr. Manas. We can come back at 4 o'clock.
Yeah. Thank you so much, sir.